Hey, welcome to another stop on our roadmap of AI augmented design and product development. I'm Brad Scheller, and in this video, we're going to examine the heart of the product design process. This week, we're going to dive into what I call the front end of innovation, the concept generation and selection phase. Now, this is where the real magic happens. This is where you take all that customer research, all those insights you gathered, and transform them into actual product concepts. And then, crucially, you learn how to systematically select the best ones so you can maximize your product portfolio. Now, I want to be clear about something right from the start. This is not about having one eureka moment and running with it. That's a recipe for failure. The best product teams generate dozens of concepts before selecting their winners. So today we're going to cover what a concept actually is and isn't. We're going to talk about a structured 5-step process for generating concepts. We're going to look at external and internal search methods, including lead users, and we're going to use what I call it, or what's been called, the SCAMPER Divergent Toolkit. It's pretty cool, as well as the 2-step selection process using the Pugh matrix, another great idea, and weighted scoring. And finally, we're going to look at how AI tools can accelerate all of this. So let's get started. Now, before we dive into the technical content, I want to share with you my philosophy, and this ties directly back to how AI matters in product design. So my core philosophy is simple. I'm more interested in the outcome rather than the steps you have to take, or in this course, any single grades. So I always say, try it. If you don't succeed at first, I'll give you a second chance to try it again until you get it right. And that really applies to product development. By the end of our course and in the end of your assimilation of this information, I want you to be able to be the smartest person in any room that you walk into. Pretty good goal, I think. Now, let me tell you how I'm practicing what I preach. When I graded the Kodak case studies, I didn't manually read each paper and agonize over scores. That's the old way, 2 to 3 days of work, and frankly, by paper 30, you're tired, you're biased, your standards drift. Instead, I built an AI-powered grading system, and what used to take 2 to 3 days now takes about an hour. And here's the critical insight, and this applies directly to product design. The quality of the AI output depends entirely on the quality of the input, how you design your system, how you design your criteria. My grading AI works because I invested significant time creating detailed rubrics and prompts. If I had given it vague instructions, I would have gotten vague results. This is exactly what happens in AI-augmented product design. When you use AI for concept generation or validation, your results will only be as good as the specifications, criteria, and prompts you provide. Garbage in, garbage out. This principle, quality inputs create quality outputs, will be a theme throughout today's lecture and, of course, our course. Remember it when we get to AI augmented innovation at the end. So on with our presentation. And we're going to start with a fundamental question that most people never really answer. What is a concept? Now, a concept is not a final design. It's an approximate description of technologies, principles, and forms. Think of it as a napkin sketch, just enough detail to communicate the core idea, but not manufacturing specifications. Now, a good concept includes 3 things. 1, the core working principle. How does it work? 2, a rough form factor. What does it look like? 3, key technologies involved. What enables it? For example, a concept for a new coffee maker might be, and get this, a thermal carafe system using vacuum insulation that brews directly into a double-walled container, eliminating the need for a heating plate. That's it. No exact specifications, no dimensions, no material information, no CAD drawings, just enough to understand the core idea. So here's the trap. And this is a term that is called satisficing. It's Herbert Simon coined this term. It's a combination of satisfy and suffice. It means settling for the first option that meets minimum requirements. That is deadly in product design. The first acceptable idea is almost never the best idea. Research continuously shows that the quality of your final concept correlates strongly with the quantity of concepts you generate initially. That makes sense? Do not stop at the first acceptable idea. Push through to 20, 30, maybe even 50 concepts before you start selecting. So coming up with a great concept is the goal, but let's talk about the process. Concept generation isn't just brainstorming. It can be a structured 5-step process. So here are the steps. Step 1, clarify the problem. Before you generate any concepts, make absolutely sure you understand the problem. Go back to your customer needs. What are you actually trying to solve? Most failed products fail because they solved the wrong problem beautifully. Step number 2, search externally. Now, this is critical and often slipped. Before your team sits in a room generating ideas, look outside. What solutions already exist? What have other industries done? What are lead users creating? We'll talk more about that in a moment. Step number 3, search internally. Now you bring your team together. You leverage your collected knowledge and experience, but notice this comes after external search, not before. Step number 4, explore systematically. And this is where tools like SCAMPER and morphological charts come in. Don't just brainstorm randomly. Systematically cover the solution space to make sure you haven't missed anything. And we're going to go through that in a little bit. Step number 5, reflect. Before moving to selection, step back. Do your concepts actually address the customer need? Or have you fallen in love with a clever solution that doesn't solve the real problem? That's a critical issue. One key tactic that makes all of this work, problem decomposition. Now, the way that works is you take a complex problem and you break it down into subproblems. For an electrical scooter, that might be power source, motor type, control system, frame design, braking system. Now you can ideate on each subproblem separately, then combine solutions in a creative way. This transforms one overwhelming challenge into 5 manageable ones. And that is a significant step. So I mentioned 2 types of searches, the external and internal. And here's a counterintuitive insight. You should do external search first. Now, most teams jump straight into brainstorming. That's internal search. But this is backwards. Before you invent something, find out what already exists. External search has 3 main components. First, lead users. And these are people at the extreme edge of your market who have needs so acute that they've already created their own solutions. And an example I keep coming back to is GitHub with open source code. Those developers are brilliant. They come out with ideas that Anthropic and Gemini and all those people start to steal and put into their product. We'll dive deep into this on the next slide. Second, patents. And here's a secret weapon, expired patents. Patents expire after 20 years. And then that's intellectual property is free for anyone to use. Search Google patents for solutions to your subproblems. You might find that someone already solved your challenge decades ago. Next, brain benchmarking. Take apart analogous products, not just competitors, but products from other industries that solve similar subproblems. How does a high-end espresso machine handle precise temperature control? That might inspire your baby formula warmer. Next, internal searches. Now, this is where traditional brainstorming happens, but let's do it right. The golden rule, defer judgment. During ideation, there are no bad ideas. Criticism kills creativity. Save evaluation for the selection phase. Your goal is quantity at this stage, quantity over quality. Research shows a strong correlation between the number of concepts generated and the quality of the final solution. IDEO, the famous design firm, said it best, fail often to succeed sooner. And that applies. So generate 50 mediocre ideas, and hidden among them might be 3 to 4 gems. A great source for finding ideas is lead users. And lead users are one of the most powerful concepts in product innovation. And this ties directly to your 3M case study this week. MIT professor Eric von Hippel pioneered this research, and here's his key insight. Lead users face needs months or even years before the mass market, and because they can't wait for companies to solve their problems, they often create their own solutions. Think about what that means. They've already done your R&D. All you need to do is find them. The classic example is mountain biking. Who invented mountain bikes? Not bicycle manufacturers. It was cyclists in Marin County, California, who wanted to ride off-road. They modified their bikes, stronger frames, better brakes, different gearing. Manufacturers noticed these modifications and eventually commercialized them. The innovation process goes. Lead users create, manufacturers observe, mass market adopts. GitHub is a classic example of that. Your 3M case study this week shows how a major corporation systematically leverages lead users across 60,000 plus products. 3M calls it bootleg innovation. Employees are encouraged to spend 15% of their time on unauthorized projects, and they actively seek out lead users in their markets. So how do you find lead users? Ask yourself, who has the most extreme version of the problem I'm solving? Who has already tried to solve it themselves? What communities or forums do these people hang out in? And this is increasingly important. Communities like school or different forums on Discord are places to search out. So go to where passionate amateurs and frustrated professionals hang out. That's where you're going to find innovation at the edges. Next, when you're stuck in ideation, SCAMPER is your systematic rescue tool. It's an acronym, and it gives you 7 different lenses to transform an existing concept into something that might be more fruitful. S, substitute. What can you swap out? Different materials, different power source, different user interface. C, combine. What can you merge? Can you combine 2 products into one, 2 features, 2 user needs? iPhone combined various components into its iPhone. A, adapt. What can you borrow from elsewhere? How do other industries solve similar problems? M, modify. What can you change in scale, shape, color, texture? What if it were 10 times bigger or 10 times smaller? P, put it to other uses. What else could this be used for? Who else might need it? E, eliminate. What can you remove? Often, the most innovative products are simpler than competitors. What's truly essential? R, reverse. What if you did this backwards or upside down or in the opposite order? Let me show you how this works with a mundane example, the umbrella. So if you take that apart and modify pocket size, the folding umbrella, put to other uses, add solar panels, an umbrella that charges your phone, eliminate, remove the handle, hands-free umbrella that attaches to a backpack, reverse, open upside down, the inverted umbrella that doesn't drip when you close it. Those are some examples. From one boring product, we just generated 4 distinct concepts. Now imagine running Scamper on each of the subproblems of your product. You'll generate dozens of concepts systematically rather than hoping for inspiration to strike on the few that you have. The next step, after you use Scamper and brainstorming to generate solutions for each subproblem, you need a way to organize and combine them systematically. And that's where the morphological chart comes in. It's also called the combination table, and it's one of the most powerful tools for systematic concept generation. Here's how it works. First, you have rows that are your subproblems from problem decomposition that we did. Second, you have columns that are alternative solutions for each subproblem. So let's take a look here. Look at this electric scooter example. Power source, battery, solar or fuel cell. Motor, hub motor, mid-drive, or friction. Control, throttle, pedal sensor, or automatic. Now, every unique path through this table creates a distinct concept. The highlighted path shows solar power plus mid-drive motor plus pedal sensor is one specific concept. Do the math with just 3 options per subproblem across 3 subproblems. You get 3 times 3 times 3, 27 potential concepts. Add a 4th problem with 3 options. Now you have 81 concepts. Most teams won't evaluate all 81, but the morphological chart ensures you're aware of the solution space. It prevents you from fixating on one combination just because it was the first one you thought of. When I review client or student concepts, I ask, did you consider X? Teams that used a morphological chart can show me they considered it and explain why they rejected it. Teams that don't often say, oh, we never thought of that. That's a fault. So we've used these steps so far to come up with a tremendous amount of great concepts. Now we pivot from divergence to convergence. How do we pick the winners? Now, most teams rely on gut feeling. Someone says, I like this one, or this feels right. That's a problem. That's a real problem. Why? 3 reasons. First, what hippos, the highest paid person's opinion. In most organizations, whoever has the most seniority or loudest voice wins. That's not innovation, that's politics. It's a path to suboptimized performance. Second, coolness. That coolness bias. We gravitate towards concepts because they sound innovative or trendy, regardless of whether they actually meet customer needs. Let's add AI to it. That's not a strategy. That's just being cool, for coolness' sake. Third, inconsistency. Without structure, you'll evaluate concepts differently on different days, depending on your mood, who's in the room, or what you had for lunch. The solution is structured decision making, and this means several things. Transparent. Everyone can see how decisions were made and why. Consistent. Every concept is evaluated against the same criteria. Documented. You have a record that you can refer back to. You can defend it. You can learn from it. And it's part of a 2-stage selection process. We're going to use something called the Pugh matrix for initial screening and weighted scoring for final selection. So the goal isn't to eliminate human judgment. It's to structure it so the best idea wins, not just the ideas with the most vocal advocates. So we're going to get to something called the Pugh matrix. It's a tool that was developed and it's very strong. You start with, say, 20 plus concepts from your generation phase. Now, in those days, you couldn't do detailed analysis on all of them. That would take forever. So you do a quick qualitative comparison. I would argue that now you can do more detailed across all of them using AI, but we'll get to that. The Pugh matrix uses a simple plus, 0, or minus scoring against a reference concept. That means plus means better, 0 means neutral, minus means worse. No detailed weighting, just no calculations, just rapid evaluation and assessment, relatively. This quickly narrows your field to roughly your top 5 concepts. Some get killed outright, some get combined with others, and some move forward. Stage 2, you score with a weighted matrix. Now you invest serious time. With only 5 concepts remaining, you can afford detailed analyses. You score each concept on a 1 to 5 scale against each criteria. Multiply by the importance weights, and you calculate the total scores. This is where your customer need prioritizations pay off. The most important needs get the highest weights. The output, ideally, 1 final concept moves forward, or sometimes 2 that are close enough to prototype both. This 2-stage approach is efficient. You spend minimal time on concepts that clearly won't make it, and maximum time on the serious contenders. Now, the Pugh matrix was named after Stuart Pugh, and it's elegantly simple. Step 1, you choose a reference concept. This is your benchmark, often an existing product or your most conventional concept. Everything else is compared to this. Step 2, for each criteria, you rate every other concept as, is it better, plus, then the reference, is it about the same, 0, or is it worse, negative. Step 3, you sum the pluses and minuses to get a net score. In this example, concept A scores 1 plus 1 overall. It's better on cost and speed, but worse on comfort. Concept B breaks even, better on speed, worse on cost, same on comfort. The outcome isn't always pick the highest score. You have 4 options. You can continue and move the concept forward as is. You can combine. Maybe concept A cost approach combined with concept B's comfort would be stronger. You can revise. concept shows promise but has a critical weakness. Go back and improve it. Or you can kill it. The concept's clearly inferior. Stop wasting time on it. So, one key insight. The reference concept might win. Sometimes after evaluating everything, you realize your benchmark was actually your best option. That's valuable information. It tells you not to change for change's sake. So next in the Pugh matrix process is stage 2, where you get quantitative. Instead of plus, 0, negative, you assign actual scores and weights. And here's how the weighted scoring works. First, you assign weights to each criteria based on customer importance. In his model, performance might be 40%, reliability 30%, cost 30%. And again, his model, weights must sum to 100%. Then you score each concept on each criteria from 1 to 5. Concept A might score 4 on performance, 5 on reliability, 3 on cost. Finally, you multiply the scores by weights and then sum them. In this example, 4 times 0.4, et cetera, equals 4 total. The highest total score wins, usually. But watch out for 3 common pitfalls. First, groupthink. Everyone agrees to avoid conflict, even when someone has valid concerns. Encourage dissent. The person raising red flags might save you from a disaster. Second, winner's curse. Selecting a concept that has hidden fatal flaws. The numbers look great, but there's a technical risk nobody scored because nobody understood it. Next, weight manipulation. Somebody really wants concept B to win, so they quietly adjust the weights to favor its strengths. Set weights before scoring to prevent this. The validation rule. Numbers on paper don't always equal success in the real world. When uncertainty is high, especially technical feasibility, build something. A simple prototype will teach you more than endless scoring sessions. I want to interject my own thoughts on the Pugh matrix. I think it's a great concept, but it needs to be updated with the availability of emerging AI. Here's something I don't think most textbooks get. Where do you get your criteria from? You can't just make them up or use generic lists. Your criteria must be specifically tailored to your business situation. Think about it. The criteria for evaluating a medical device is completely different from the criteria from a consumer app. And even within medical devices, hospital devices differ from home care devices. So how do you develop the right criteria? I think there are 2 parallel tracks. First, market success criteria. Use AI deep research tools, Perplexity, Clause Research, Notebook LM Deeper, to get industry reports and analyze why something is successful in a market, your target market. What are the critical success factors? What caused competitors to fail? What do customers say about the value that they receive and look for in reviews and forums? Second, organizational capabilities. Use AI-powered interviewing to honestly assess what your team can actually execute. What are your core strengths? What resources do you have? What are your technical limitations? What's your realistic budget and time frame? Then build your rubric. So, 1, brainstorm criteria categories by synthesizing your market research with AI. 2, add must-have constraints that immediately eliminate non-starters. Regulatory requirements, hard budget limits, non-negotiable timelines. Those are killers. Third, include both external criteria like market fit and internal criteria such as can we actually build this. 4, weight the criteria before you score any concepts. And I am different in mindset from the Pugh approach where all the criteria need to add up to 100. Sometimes similar criteria are equal in weight. So first you want to weigh those. This prevents any human tendency to adjust weights in favor of a concept you already like. Now you have a robust rubric, and that is your quality filter. Invest time into getting it right. Next, I want to share with you what I actually do. And this is only based on my own experiences, but I think it's valuable. So I want to show you how I actually use AI throughout the concept generation and selection process. Now, this is not about replacing your thinking. It's about amplifying it. First, your research stack. I use Perplexity, Notebook LM Deep Search, Google's Deep Research, Claude, etc., to gather current market intelligence, competitor information, customer insights. I look at communities such as Reddit, School, SKOOL communities, Discord communities, etc. But I don't stop there. I feed those search results into Notebook LM. There are a lot of ways to interface to feed from those applications into Notebook LM. And I use Notebook LM basically as a place for my repository for ideas, as well as the ability to synthesize those ideas. Within Notebook LM, I will create video tool for overview. I will create a slide deck for overview. I will create an infographics for overview. I will create a mind map to look at all the different components and how they interact with each other. This is a great technique for brainstorming. Now, what happens next is I can share those outputs and download them and reload them into Notebook LM to increase the depth of my repository of knowledge. And I can use links to Notebook LM through the Notebook LM MCP server or the open source version to allow me to use other AI models to access that knowledge repository to get other insights. It's always great to get other insights from other tools. They do different things at different strengths. Second, I use customized AI skills for ideation. Now, skills are basically AI generated guides or cookbooks on how to do something. Now, they're now easy to create with most of the LLMs or large language models. They define the steps, the input requirements, what the outputs need to look like, etc. Don't be afraid of them. Learning to use skills will be a critical skill in your career. You can build skills that systematically apply SCAMPER to your subproblems. Ask the AI, apply all 7 SCAMPER techniques to the problem of such and such. It will generate dozens of concepts rapidly. And here's the key workflow. You're using AI also to diverge first, generate lots of options, and then you use the Pugh matrix or my version of it to converge. You filter down to the best ones. The AI expands your thinking. Your structured process narrows it. Third, the warning, and this is critical, AI lacks tacit knowledge. It doesn't understand your company culture, your manufacturing constraints, your regulatory environments, or the unspoken rules of your market. AI creates options. You must provide the judgment, and that happens during your creation of your rubric or Pugh matrix. Never outsource the final decision. You own it. Use AI to see more possibilities than you find alone. Use AI to validate and define the selection, but the final judgment is the human judgment. Now, for my students, let me walk you through your 8-step team process for this week. And this is not just a checklist, it's a structured workflow that mirrors how professional product teams operate. Step 1, team communication. Before you do anything else, establish how you're going to work together. Set up your communication channels, agree on meeting cadence, define roles. This prevents chaos later. Step number 2, interest discovery. Interview your own team members. What industries or market segments generally interest them? Where's your passion? You work harder on problems that you care about. Step number 3, do segment research. Once you've chosen a direction, perform detailed research on that segment. Use the AI research stack we discussed, Perplexity plus Notebook LM, etc. Understand the market deeply. Step number 4, create your Pugh rubric. This is the new slide we just discovered. Develop criteria specifically tailored to your target market and your team's capabilities. Generic criteria produce generic results. Terrible. Step number 5, use the SCAMPER process. Now apply systematic divergent thinking. Use SCAMPER on each subproblem. Generate at least 20 concepts. Rough is fine. Quantity matters. Step number 6, use the Pugh matrix selection. Apply your custom rubric to filter alternatives, kill the weak concepts, identify the top contenders. Step number 7, define specifications. Use an interview process that takes that information on the criteria as well as the concept and asks you to how you would define the criteria if you were playing the role of a user. And this gets your requirements on the page. What are your top concerns? What are your things that thrill you, etc.? Step number 8, produce a requirements document of your product. Now, I'm going to give you a skill set that allows you to do that based on what the work is above, and you can apply that in your Claude application, and it'll walk you through based on all the stuff you found out. Here's your requirements document, and that is due Sunday at 11:59 p.m. And I ask you, please don't wait till 10 p.m. on Sunday to do this. So let me leave you with the core mindset for this week and the rest of your product design careers. Quantity first, quality second. This might feel counterintuitive. We're all trained to seek quality from the start, but in concept generation, that instinct will hurt you. The best concepts often emerge from combining or refining mediocre ideas. Generate 50 concepts. Don't judge them while you're generating, and switch gears and rigorously select. The best teams resist the urge to converge early, expand possibilities, then rigorously narrow them down. Most teams do the opposite. They converge too fast on a good enough concept, never exploring what might have been. Don't be that team. Use the tools, SCAMPER, morphological charts, lead user search. Use AI to accelerate your external search. Then use Pugh matrices and weighted scoring to select systematically. This week, I want to see 20 plus concept sketches from each team, not just 20 polished designs, 20 rough ideas, showing me you expanded the solution space before narrowing. Good luck, generate wildly, and select wisely. Have a great and productive week. Thank you for viewing this video.